how is NH3? Notice remember I gave you the Lewis dot structure, found out the total pairs, electron geometry is tetrahedral, true shape is trigonal pyramid. Now, how would that work if you were using the PhET simulation? So if I were to go on to the website here, okay, so NH3, you had three hydrogens, 1, 2, 3, and 1 lone pair, okay? So what happens is that it looks like a little space alien here, okay? Now, if I look at the electron geometry, or the number of pairs of electrons, 1, 2, 3, 4, this is where we get tetrahedral, and the molecule geometry is the 1, 2, and 3. And so what you get is you get trigonal pyramid. Okay, so this is, you could use the website to sort of help you build the molecule so you can see it in 3 dimensions and how it looks. Or what you can do if you want is you can use this little table to try to figure things out. Okay, so this is something for you to do, and most of the time, these do work well together. Okay, now one final thing I'm going to add on, and then that will be it. That just messed up a bit. Okay, is I want to talk about double and triple bonds. Okay, so let's say, for example, if you have here down in the notes, it says in double or triple covalent bonds, all the electrons in the bond are confined to the region between bonded atoms. As a result, the electrons in a multiple bond collectively have the same effect on the shape of a molecule as does a single covalent bond. Now, what do I mean by this? Okay, so if we take a look at this, so let me say, for example, let's say we have CO2. Now, if we take a look at the Lewis dot structure, what you have is you have O double bond C double bond O. Now, if you take a look at the central atom here, notice here carbon has 4 pairs. Okay? Now, but here is the thing. Because they are in double bonds, there's 2 shared pairs on each side, what we do is we merge the double bonds. That's what I call DB. And so what you have is, in this case, to determine the shape only, you would have this. So now what you have for the carbon is you have 2 pairs. Now, look, and this PhET simulation might work a little bit better. So if you were to screen share, so let's do that one. Okay. So let's say we reset. Okay. Now, so I'm just going to move my face down here a bit. So what we do is we clear everything. So right now we have carbon, and we add 1 pair, 1 double bond, and we add another double bond. So notice the 2 bonds are in the same area, so they create a straight line. So the electron geometry is linear. That's where most of the electrons are located. They are located 180 degrees from each other, and the molecular geometry is also linear. Okay, so when you take a look at double bonds, what happens is you are assuming that the double bonds merge into one when you're determining the shape. Now, if I were to clear this, okay, So let me stop sharing here and just get my face off the picture here. So hopefully it'll be a little bit, stop the video. Okay. So what I'm going to do is let me give you one final example of this. Okay. So let's say we've done one, I don't know. Let's say we had, for example, let's say we did SO4. No, that's not SO4. Let's do, I don't know. Let's say NO3, I believe, -1. Now, when you drew the Lewis dot structure, it looks something like this. Now, remember, when you're thinking about the shape, the double bond has merged into one. Okay? And so what you have is you have, oopsie, you have O single bond N, okay? And then you have O, O. Now, so if we were to take a look at the shape, okay, so what we would have is, again, using the bond, so you would have 2 singles and 1 double. Okay, and notice the trigonal geometry, the molecule geometry is trigonal planar. The electron geometry is also trigonal planar. Okay, why is it trigonal planar? Because if I were to rotate it around, you notice there is all on a straight line. So if I were to cut everything through, like using a ruler or something to cut all 3, they would all be cut evenly. And that's why it's called trigonal planar. Trigonal because there's a little triangle. Planar because what you have is they're all on the same plane. Okay, so that is what I wanted to do with your notes from last day. Unfortunately, we had some technical difficulties, so I just added on a little bit to the video. Okay, so hopefully that is it. All right, and if there's any questions, feel free to email me. All right, thank you very much. Have a good day. Bye-bye.